So this is chapter 2 of the history section. We're going to talk about classification, also known as taxonomy. And again, it hits on the need of human beings to label things, to give them names, and to see the relationships among the different things. As that, the caption up here is he's pointing at the spiky end of course, people and dinosaurs didn't live together, but it's a cartoon. The spiky end of a stegosaurus going, now this end is called the thagomizer, after the late Thag Simmons. So you can kind of figure out where the name came from, other than that. One issue of classification is that different places have different languages, and the local names for things, even in places with the same language, the local names for things may vary from one place to another. So a groundhog may be a different thing in different places. Here it's Know Your Insects, and they just have names like Bob and Linda and Carol. But when science was starting to beginning, and different countries in Europe were trying to get into a system that could be kind of a gathered, shared system. They did run into a problem with things like local names and different languages. This I expect you can probably read big enough. The first expression to learn in any foreign language is, "I'm sorry, I don't speak your language." So they came up with an approach. People who were doing science had what's called classical educations. They'd gone to universities, and a classical education virtually always included classical languages, Latin and Greek. So what happened was people decided, okay, if I'm going to write in Germany and somebody in France can understand it, and somebody in England can understand it, and somebody in Italy can understand it, why don't we all put it in the languages we've been taught? So we will write things and name things using Latin, and sometimes Greek, but mostly Latin. So the classification system was built by a lot of people. It went back a long way. We talked about kingdoms in the first chapter, where things have been gathered into groups going way back to the ancient Greeks. But here, there was a push to come up with a more organized system that had rules in it that could be followed by everybody, and how do we apply the Latin to this? And a number of people worked on this. What happens in science history is very often one person will kind of get the credit for things because they were instrumental in kind of pulling stuff together. But they didn't work all by themselves. They were just kind of the point person, or the person out in front. And a guy named Carl von Linné was one of those people. Now, Carl von Linné, putting an organized system like this together, you need to be kind of a little bit OCD. And he not only wrote things up in Latin, he changed his name when he wrote things up and put his own name down on things in Latin. So he was known as Carolus Linnaeus, not Carl, not von Linné, Linnaeus. We like to organize things in groups, right? We've got our family, we've got our extended family, we've got our community, we've got our state, we've got our country, and organization for classification was similar, like who's most related and was going to be in a very small group, who's related a little bit beyond that but needs to be in a bigger group. So dogs and wolves are closely related, and they're related to foxes, but not quite as closely, so they should be inside the same group, but in a slightly bigger group that includes foxes and dogs. And inside a bigger group, of things that eat meat and have certain features together. So then the dogs and the cats are in a somewhat bigger group together. But cats are in their own smaller group, dogs are in their own smaller group. Foxes are, I think, in their own smaller group. I'm not a mammal person. And so the groups that we kind of wound up with, King Philip came over from Germany slowly, if you ever learned this at a lower class. At the very top was kingdoms. We now put domains above kingdoms, but I'm going to give you the classic Linnaeus system. So the big groups are the kingdoms, and in Linnaeus' time it was animals and plants, and that was it. So dogs and wolves would be different species inside the same genus, different species. I think they share the family with the foxes. They share the orders with the cats. They share the class with other furry animals. So they share a class with cows and whales. They share a phylum with reptiles and fish, and they share a kingdom with all the other animals. It's gotten a little bit more bizarre than that. We'll talk about that in a minute. But this is the basic structure. Big to little. General to more and more specific. It's not an accident specific and species have the same root word in Latin. And so people would look at things and go, okay, well, I think they need to be lumped together, and I think they need to be lumped together. And somebody goes, well, yeah, but I think these two groups are connected, and nobody's connected them before. But I don't really want to bump the whole system up and down the ladder. How do I connect things or split a group where I think part of the group it needs to be kind of more linked and another part needs to be more linked, but they need to be different inside this order, for instance? Well, they came up with ways to kind of fiddle the system. Take the bats. There are two major groups of bats. The big bats that are like things like fruit bats, and the small bats that are around here eating bugs at night. The little bats, the microcoroptera are the little bats, the macrocoroptera are the big bats. There's been an ongoing debate as to whether they all belong in the same order, or they belong in the same order, but they should be split into suborders to acknowledge that they are fairly different from one another, but the order tells us that they're all related in a particular way. Or they should be in their own separate orders linked together into a super order that again shows that there's a connection, but the connection is a little weaker because they've been split into their own orders. So links can be super orders, splits can be suborders, and you can do that with any of the groups. There could be subkingdoms, there could be subspecies, there could be super classes, there could be super families. Basically, that's why it says super group and subgroup. Any group can be split or linked that way. That gives you a lot more levels when you start to argue about what belongs where. And people do. They argue about whether this person's classification makes any sense. And here's the rule for arguments. Say I think that the macrocoroptera and the microcoroptera should be in their own separate orders. I can write a paper about that, and I can continue on my other papers to refer to those two groups as orders. I'm allowed to do that. I'm allowed to change their designation on the ladder. But I'm not allowed to change the name of the group. I'm not allowed to say, I don't like macrocoroptera, I'm going to call them biggest badiuses now, and littlest badiuses over here. Because those are the group names, and people know what you're talking about because they know the group names. They may look at your paper and go, I've never seen people put those into two separate orders before. I guess they've decided that the classification is a little bit different. But I know what groups they are because I'm not allowed to change the names. There are ways to change the names, but it involves a whole appeals process, and it goes through a committee, and used to be in London. I think it's in Geneva now, or the other way around. But typically, once a group has a particular name, you keep it that way so that everybody knows what you're talking about. Even if they're used to it being an order and suddenly you're calling it a superfamily. They still know what group it is because they know what the name means. So arguments, what you're allowed to change and what you're not allowed to change. You're allowed to change the designated levels and just keep talking about them the way you want to talk about them, but you're not allowed to change the group names because that's too confusing. Another thing that Linnaeus is credited with is solidifying the rules for naming the smallest, most related groups, the species. Is that the larger groups get single word designations. The species get two-word designations, kind of the way people do. Remember postmodernism, you kind of reflect your culture and your learning in the way that you approach the world. Well, he decided that the way that people were named with two names, where you had your family name, which linked you to a group, and then you had your own given name that says, okay, I'm this person in this group. It's just with people, the rules are not so set, where you could have two people in the same family with the same name, but that's confusing. If you're in the Screen Actors Guild, you're not allowed to do that. You're not allowed to have two actors in the Screen Actors Guild with the same first and last name. Even if your first and last name matches somebody else, they go, no, you gotta change it. So Linnaeus came up with a way to name species that involved two name naming, and that's called, so species names, binomial, two names, nomenclature, naming. That's why the gnome thing starts up, that's a C. And there are words, there are two words. I don't know if this works in other languages, but in English, a species name is considered a foreign term. If you're writing prose and somebody is suddenly speaking French, it's supposed to be set off, so you don't confuse your English reading readers. They go, oh, it's a foreign language. It's not words I've never seen before in English. So you put them in italics. If you're writing longhand, you're supposed to underline them. Same thing's true for species names. So they're italicized or underlined. I hope everybody knows that the W/ means with. An abbreviation for a species name is the first initial of the first word and then the second word. Most of you know of one of these, E. coli, right? It's something you don't want to get in your chopped meat. E. coli is a nasty bacterium, doesn't work and play well with our bacteria, it can make you sick. But E is just the initial for Escherichia, which is the first word of that species name. And coli is a Latin word meaning of the colon, but it's the second word of that species name. There's also rules for each word by itself. The first word is the bigger group that the species is in. So backwards from human names, unless you're Asian, but European names is that usually the family name, the group is second, and the more particular name is first. Linnaeus reversed them. I think it has to do with the way Latin works. I don't really know. I took Latin, but I don't remember that as a detail. And the first word is the bigger group, the genus that the species is in. Now, some people call the second word the species, which it's not. Some people call it the specific, which I think is just confusing. That second word doesn't mean anything by itself. The same way that, my first name, Michael, doesn't really tell you much. For people of my age, if I'm in a group, a room full of men my age, there's sure to be at least another Michael in there. Not going to be another Michael with my last name, and that's kind of the way this works. You can use the same second word over and over and over again as long as it's in different genera. Genera is the plural of genus. Coli, of the colon, is a second word for a tremendous number of species of things that live in colons or are somehow associated with colons. But each one would have its own particular genus. And that's the way it works. So very often the second words are size descriptions in Latin, or colors, or spiky or spiny or thick. They use all sorts of Latin words for the second word. Another rule: you can name a species using the second word from somebody's name or a place name. But even though that name for them would be capitalized, in the species name, you don't capitalize it. If it's a place name, you don't capitalize it. When you come into the lab, we've got little lizards in the tank across the room. Their species name is Anolis. That's their genus name. Anolis carolensis. They're originally discovered in the Carolinas. Carolensis is Latin, of the Carolinas. But you don't capitalize the C, because that's the rule. You don't capitalize the second word. So how do you decide who's related to whom? There's not an accident. I'm leaving space here. If you read the first book of the Bible, Genesis, you get an idea of how classification used to work. They would lump together in groups things based on either very superficial things they look like or things that they did. So the whole group was created on one day of beasts of the air. And the reason for that is they figured if you flew, you were related to anything else that flew. So birds and butterflies and flying fish and anything that flew was related to, they were in their own group. They lumped by analogy. Things that were long and round and skinny and wiggled were lumped together. That's why parts of the Bible that actually talk about a roundworm parasite, we'll talk about later in the semester, are actually translated in the Bible, because it's translated in the original wording, as serpents, because they were all lumped together into the same long wiggly group, because they were similar to one another. And it turns out they're not at all related, because structurally they're very different. Is that you look inside a snake and you find a backbone and a lot of ribs and a lot of organs similar to ours. You look inside a roundworm, there's no internal skeleton. Its organs are very, very different from ours. It's just not structured the same way. And then now we put things in different groups using more homologous comparisons. We've gotten away from analogous. But when things do the same thing, they often do resemble each other. And that's a type of evolution at play called convergent evolution. Why are so many animals long and round and skinny and wiggly? Because if you live in tight places, that's a very good shape to have. And so even though you're not related, that shape is one of the best ways to work a particular job in the world. And your evolution kind of takes an ancestor working in that kind of situation and modifies it over time. It picks the successful forms and discards the not successful forms. And you wind up with a long, round, skinny structure. Things that fly, there's only so many ways to do that. Most of the time you need wings. So convergent evolution produces butterflies and bats and birds that have wings, but the wings are structured differently. Bird and bat wings are structured somewhat similarly, but different enough because you have birds and mammals. Butterflies, completely different type of internal structure, but they look superficially the same because if you're gonna fly, you kind of need a structure that you can get off the ground with. So you get convergent evolution. It shows evolution is kind of a push toward being successful in a particular circumstance, doing a particular thing, and sometimes there's only so many ways to do that. So you'll see evolution produce very similar forms in things that aren't really very related to one another. This side, you can start with something and split it into groups where the structures become very different because they're doing different jobs. They're reacting in the world in different circumstances. And for that, you get what's called divergent evolution. A bat is more closely related to us than it is to an eagle. Because bats are not that closely related to birds, but they superficially look like birds from convergent evolution, and they don't look like us because their ancestors, which we share ancestors with the bats, but they went from being gliders to being more efficient gliders to being flyers, and it produced a very, very different form in them, even though inside they've got the same basic bones. Okay, picture. So here's a bat wing, here's our arm, here's a lizard. Our arms have a single starting bone that has a ball and socket joint at the top. It's on a pterosaur, it's on a bird, it's on a horse, it's on a, what is that? A plesiosaur and a dolphin. Then two bones. Sometimes one of them's not used for the same thing, so it becomes smaller. There's two bones. The two bones here are harder to see. There, there, there. Then a set of wrist bones. Those vary a little bit more from one group to another. And then what's at the end? A hand, a lizard foot, a wing supporting a membrane in a different way. Wings that don't really support there's feathers that are attached to these bones that produce the bird wing. The bottom of a horse leg, a flipper on a plesiosaur or a dolphin, is that the flippers and the wings are analogous. They're doing the same thing, but they're using a different structure to do it. And so you get divergent evolution. All of these are vertebrates, and they share an ancestor if you go back far enough. You gotta go back a really long way. But they share an ancestor that has similar internal structures. Think about it, Ed. The class Insecta contains 26 orders, almost 1,000 families, and over 750,000 described species. But I can't shake the feeling we're all just a bunch of bugs. I used to have an insect professor, not a professor who was an insect, but a professor who taught about insects, who hated it when I referred to insects just generally as bugs. Because there is a group of the insects that is specifically the bugs. So if you're an insect person, you go, no, only the hemipterans are bugs. Here's one where the editor knew how to do a species name. Johnson, back off. It's an Armandia litterdali, all right, but it's rabbit. Litterdal was a famous biologist. A lot of insects are named after, or named in his honor with the second word. You're not supposed to be able to name stuff after yourself. People find ways around that. But here, they put it in italics. They made sure the first word was capitalized and the second word was lowercase. Here they didn't do that. Hey, what's this Drosophila melanogaster doing in my soup? A Drosophila melanogaster is a fruit fly. So what's this fly in my soup? It's a classic joke. But they didn't italicize it. They did get the capital, no capital right, but they didn't do the italics right. And that happens a lot. You'll see species names sometimes not written in italics, sometimes written with 2 capital letters. I've been, trying to get the people at the Farmers Museum to change their garden labeling because they've got the capitalizations wrong on them. I don't know if they have, I haven't looked in a while. I don't even know if they've been open for a while. But this is the beginnings of classification. It's the beginning of the chapter. We have more to do.